Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I'm just going to explain the process of glycolysis. So when we talk of the process called glycolysis, this is just the process which is trying to explain how glucose is being broken down to produce energy. So when we talk of glycolysis is just a pathway. It consists of a lot of stages, a lot of steps, and these all steps which are involved in this process, they're just trying to explain to us how this important content, this important nutrient called glucose is being broken down to provide what we are calling ATP. And this ATP is just the most important form of energy which our cells need for them to do what? To function well. So we need to understand that it's not only energy in form of ATP which is produced. Instead, this process, it acts as an intermediate for other biosynthetic pathways. So what type of glucose is really broken down? So we need to understand that D-glucose is the major fuel, or it is the major source of energy in most of organisms. D-glucose is the major fuel or the major source of energy in most organisms, because we have two types of glucose. We have D-glucose and L-glucose, but between the two, the most abundant and the most used type of glucose is just D-glucose. So this D-glucose is normally broken down, okay, by the process of glycolysis to produce what we are interested in, which is what? Which is energy, and this energy is normally in form of ATP. So when we talk of this same glucose, which is broken down by the process of glycolysis, we need to understand that there is another important content, another product which is released by this process, and this important product is just what? The pyruvate. So we need to understand that two pyruvate are very important to, or are released during the process of what? Glycolysis. And then one thing we need to understand that glycolysis, it is a 10-step process. Glycolysis is a 10-step process, okay? And then this process can either take place in the presence of oxygen or in the absence of what? Oxygen. So one thing that we need to understand that when there is a presence of oxygen, the oxygen normally reoxidize the molecule which we call the NADH. So in the presence of oxygen, we need to understand that the role the oxygen will play is just to reoxidize the NADH to form an important product, and this product is known as what? Glycerolhaldehyde 3 phosphate. Glycerolhaldehyde 3 phosphate. So now we have said that the process of glycolysis, it is a 10-step process. It is a 10-step process, but we don't really need to be worried much about this process, because these 10 steps are being divided into two phases, whereby we have the first phase, which is known as the preparatory phase, and this phase, it has 5 steps. Then the last phase are not preparatory phase. So the last phase are known as what? The payoff phase. So remember, we have the first reactions, and these first reactions are just giving us what? The preparatory phase. And during the preparatory phase, this is where the two molecules of ATP are being invested. Remember, two molecules of ATP are being invested. Then we have the last 5 reactions. So these last 5 reactions are making up the what? The payoff phase. The payoff phase. And during this payoff phase, we need to understand that there is energy conserving phosphorylation, and free energy of glucose is conserved in the form of ATP. So during the payoff phase, we need to understand that the energy is now being what? Is now being conserved in form of what? ATP. And this energy is simply coming from what? Glucose. So let me repeat once again. Glycolysis has 10 steps, and these 10 steps are being divided into 2 phases. The first phase, it is the preparatory phase, which has 5 reactions or 5 steps, and then the other phase is known as the what? The payoff phase. Now, during the preparatory phase, we need to understand that 2 molecules of ATP are being invested, and then during the payoff phase, we need to understand that glucose is conserved in the form of what? ATP. So guys, please make sure that you subscribe to our YouTube channel, and make sure that you also register with Excel Academy. So let's quickly move on and look at what exactly happens in each and every step. So we'll start with the first step, which is making part of the preparatory phase. So the first reaction, which is the first step, it involves the phosphorylation of glucose. Phosphorylation of what? Of glucose. In short, there is addition of a phosphate group on glucose. So the first reaction, it is involving the addition of a phosphate group to what? Glucose. And this glucose, okay, this glucose we are talking about is simply the what? The D-glucose. Remember, we are just simply dealing with the what? The D-glucose. The addition of a phosphate group to what? To glucose. And we need to note that this reaction is normally irreversible. This reaction is normally irreversible. Okay. Now, this reaction needs an important ion. Take note of that. The first reaction, it is the phosphorylation of glucose, which simply means that there is a reaction between glucose and a phosphate group. In short, a phosphate group is being added to a glucose. And then one thing that we need to understand, that this reaction is irreversible. It cannot be taken back. Then, since this reaction is not taken back, we need to understand there is something that is needed. Okay, yes, quite all right. An enzyme is needed, which is known as the exokinase. So an enzyme called exokinase is needed, but there is also an ion which is needed, and this ion is just the magnesium. So this reaction needs what? Magnesium 2+. This reaction needs magnesium 2+, but we need to remember that this reaction is helped by the presence of an enzyme called what? Exokinase. Okay. Now, this exokinase has a high affinity. Remember, this is the enzyme which is helping in this reaction. So this exokinase has high affinity okay, has a high affinity. That means that it has a low km, okay, and this high affinity of hexokinase ensure there is what supply of glucose to all the tissues, okay, and by what? By the process of phosphorylation. Remember that, okay, remember that the cells in every tissue, because we have a group of cells, and this group of cells, they work together to form what? A tissue. So the cells in the tissue, for them to operate, they will need what? Glucose. Now, for the glucose to be available in that cell, it is due to the low affinity, to the high affinity of an enzyme called hexokinase. So this enzyme, which has a high affinity, it makes sure that there is a supply of glucose to all the tissues. It makes sure that every cell has access to, every tissue has access to the what? To the energy. Okay. Now, we need to understand that there is an enzyme, okay? There is an enzyme which is regulating the presence of hexokinase. Remember, hexokinase is doing the job, right? It is make sure that there is a total supply of glucose. But there is also an enzyme which is making sure that it's controlling the presence of what? Hexokinase. Now, this enzyme is known as what? Glucokinase. And glucokinase is an isoenzyme which is found in what? In the liver. Okay? And this glucokinase has low affinity because this guy has high Km. This simply means that this guy has low affinity. Okay? It has low affinity. That simply means that it is making sure that it is controlling how much hexokinase is there. So when glucokinase is high, you need to expect low hexokinase, and when hexokinase is high, you need to expect low glucokinase, because this glucokinase, it is the one which is converted to what? Hexokinase in most cases. So we need to understand that the glucokinase, its major job is just to regulate the what? The amount of the amount of hexokinase. Okay, so let's quickly move on and look at the reaction. So if you look at the reaction, this reaction can be represented by that. Remember, this reaction, it is phosphorylation of glucose, meaning there is an addition of a phosphate group to glucose, and this phosphate group is coming from what? ATP. So when ATP is broken down to ADP, meaning that there is a loss of a phosphate group, and this phosphate group will simply be what? Be added to glucose. It will simply be added to glucose. And remember, an enzyme which is there, which is just hexokinase, and this enzyme, it is being regulated by what? By glucokinase. Okay, let's quickly move on and look at the next part. So remember, remember that when glucose receives a phosphate group, it's going to produce what? Glucose-6-phosphate. Remember, this 6 is coming from the fact that this phosphate group has attached itself on carbon number 6 of glucose. So guys, please make sure that you subscribe to our YouTube channel and make sure that you share this video. So let's quickly look at the next reaction, which is just isomerization to fructose 6-phosphate. Remember, glucose has been formed. So when we talk of isomerization to fructose 6-phosphate, this simply means that glucose is changing from glucose to fructose, because glucose and fructose are just what? Isomers. Okay, so this reaction, it is involving the change of glucose 6p to fructose 6p, which is fructose phosphate. In terms of a reaction, we need to understand that it is just isomerization. This is glucose and then it changes to what? To fructose. If you look at fructose as what? As 1 2 3 4. Okay, and then this one as 1 2 3 4 5. This one, it is a 6 ring, and then this one has 5 ring. Okay, so if you look at this guy, you need to understand that this is fructose and this is what? Glucose. And then you need to understand that when glucose changes to fructose, that simply means that this process is just isomerization, because glucose is an isomer of what? Of fructose, or fructose is an isomer of glucose. And for this reaction, remember, it's need what? Magnesium ion, and an enzyme which is involved is just phosphohexose isomerase. Phosphohexose isomerase. So phosphohexose isomerase is the one which plays a role. Then, unlike reaction number 1, where it was irreversible, this time around we need to understand that this reaction is a reversible reaction, and this same reaction, it's need what? Magnesium 2+. Remember, this reaction is reversible, meaning this glucose 6-phosphate can be taken to fructose 6-phosphate, and this fructose 6-phosphate can be taken to what? To glucose 6-phosphate, and an enzyme which is involved is just phosphohexose isomerase, and then this reaction is what? Reversible. Okay, now after that has been done, there is a next step which is involved, and this next step, it involves again phosphorylation of fructose 6-phosphate. Phosphorylation of fructose 6-phosphate. So this will form reaction number what? Reaction number 3. So reaction number 3 is just phosphorylation of fructose 6-phosphate to form what? Fructose 1,6 biphosphate. Okay, so phosphorylation of fructose 6-phosphate to fructose 1,6 biphosphate. This simply means that there is an addition of another phosphate group on carbon number what? Carbon number 1. So if you look at this guy, this is fructose 6-phosphate. So fructose 6-phosphate will need ATP. Okay, there will be the usage of ATP in the presence of magnesium 2+. So this process will lead to the addition. When ATP is present, this will lead to an addition of a phosphate group on carbon number 1, like it has been shown there. So on carbon number 1, a phosphate group has been added. Okay, so this process, we need to understand that this process is irreversible, just like phosphorylation of glucose. Phosphorylation of glucose, during that process, it is irreversible. Same applies with this. Same applies with this same reaction. And then this reaction, it's praised as a regulatory in terms of the process of glycolysis. Okay, so take note of that. Now, we need to understand that this guy, which is a major point of glycolysis, and we need to understand that this reaction it takes place due to the presence of these enzymes here. This reaction takes place due to the presence of the enzyme which is the phosphofructokinase 1, which is just written as the PFK, phosphofructokinase 1. And this reaction is an irreversible reaction, meaning when fructose 6 phosphate is taken to fructose 1,6 biphosphate, there is no way in which this reaction can be taken back to that reaction. And this step, it is a major point of what glycolysis regulation. Now, this enzyme, which is PFK, phosphofructokinase 1, this enzyme, it is what allostatically activated by what fructose 2,6 biphosphate and also increase the ADP and the AMP. So this enzyme, it is activated by that one and also by that one. The increased ADP and AMP and also the presence of fructose 2,6 biphosphate molecule. And then this same enzyme, okay, I need to emphasize much on this. This step, it is a glycolysis regulation. Why is it a glycolysis regulation? It's because of the enzyme which is involved. And this enzyme which is involved, it's normally activated by the presence of this one and also by the presence of that one. Now, what makes this enzyme to be inhibited? So this enzyme is inhibited by the presence of excess ATP and the citrate. So ATP and citrate, they lead to the inhibition of PFK1, meaning when there is excess ATP and citrate, you need to understand that this process will not take place. But when there is the presence of fructose 2,6 biphosphate and increased ADP and AMP, you need to understand that this reaction will simply take place. Okay, so let's quickly move on and look at the next step or the next reaction. So this reaction is the fourth reaction, which is the cleavage of fructose 1,6 biphosphate. Remember that this fructose 1,6 biphosphate, it was created during reaction 1. Now there is a step, okay, there is a step whereby there is a cleavage of that same product which was formed, which is the fructose 1,6 biphosphate. So if you look at this reaction, this is how this reaction is. So this reaction, this is fructose 1,6 biphosphate. You need to understand that this molecule will be broken down, okay? There will be the process of cleavage, and this will lead to the formation of that one and that one, which is the dihydroacetone phosphate and the glycerolhalide 3 phosphate. So two molecules will be formed from fructose 1,6 biphosphate. So when this fructose is converted to that, this is just talking about the cleavage of fructose 1,6 biphosphate. So the reason why glucose had to undergo phosphorylation is for it to be converted to fructose 6 phosphate And then this fructose phosphate, the reason why it went further and went to be phosphorylated is for it to undergo cleavage so that we can have two products, which is dihydroacetone phosphate and the glycerolhaldehyde 3 phosphate. Okay, so with that being said, we need to understand that there is an enzyme which is involved, and this enzyme, it is what? Aldolase, or this enzyme is just known as the fructose 1,6 biphosphate. Okay, now we need to understand one thing. This reaction, it is reversible. This reaction, it is what? Is reversible, but because of how fast the process the process takes place, this reaction doesn't really go back. Instead, it will go to the next step. So the next reaction, it is just the what? The interconversion of the triose phosphate. The interconversion of triose phosphate. Remember that in the fourth reaction, there was the formation. In the fourth reaction, there was the formation of dihydroacetone phosphate and the glycerolhaldehyde 3 phosphate. So in the next step, there will just be an issue of exchange whereby dihydroacetone is converted to glycerolhaldehyde 3 phosphate, or glycerolhaldehyde 3 phosphate is taken back to what? To dihydroacetone phosphate. But what will happen in the normal circumstance of this process is that the dihydroacetone, okay, dihydroacetone will be converted to glycerolhaldehyde phosphate. Okay, so when this fructose 1,6 biphosphate is converted to dihydroacetone phosphate and glycerolhaldehyde phosphate, you need to understand that this guy can be converted to that and that guy can be converted to that. But when this process is taking place, you need to understand that this guy will rapidly be converted to that guy. This guy will rapidly be converted to that guy, but there is a chance of this guy being converted to that guy. So this makes the fifth reaction, and this reaction is whereby dihydroacetone is being converted to glycerolhaldehyde 3 phosphate. So when this reaction is taking place, we need to understand that this reaction is a reversible reaction. This reaction is just a reversible reaction. Okay, so let's quickly move on and look at the other part or the other phase of our glycolysis. Okay, so let's quickly move on. What happens during the payoff stage? What happens during the payoff stage? So the payoff stage, it is a very important stage because this stage, it involves the production of what? ATP and NADP. And the first reaction, which is the sixth reaction of glycolysis, when we talk of the payoff phase, we need to understand that the first reaction, which is in the actual sense is the sixth reaction, involves the oxidation of glycerolhaldehyde 3 phosphate to 1,3 by phosphate glycerate. So remember, there is dihydroacetone phosphate. Dihydroacetone phosphate was converted rapidly to glycerolide 3-phosphate. So this glycerolide 3-phosphate, it will be converted to another molecule, which is 1,3 biphosphate biphosphogycerate. 1,3 biphosphogycerate. And this reaction, you need to understand that the first of the two energy converting reaction of glycolysis that eventually leads to the formation of what? Of ATP. Now, we need to understand that during this reaction, one molecule of glucose will produce what? 2 molecules of glycerolide 3-phosphate. How is this possible? This is possible due to reaction number 2, where this guy was converted to that one. Remember that these two were converted or were produced from fractal 1,6 biphosphate. So when these were produced, this one was produced one and the other one was produced, and later on in reaction number 5, this was converted to that one, and that is the reason why one molecule of glucose is producing 2 molecules of glycerolide 3-phosphate. Okay, now we need to remember one thing, that this reaction is just involving the oxidation of glycerolide 3-phosphate to 1,3 biphosphoglycerate, meaning you find that there will be an issue of this glycerolide 3-phosphate reacting with an inorganic phosphate group, and this will happen by the presence of glycerolide from that name glycerolide 3-phosphate dehydrogenase. So this is just an enzyme which will help in this reaction, where a glycerolide 3-phosphate react with inorganic phosphate to produce this other molecule, which is just 1,3 biphosphoglycerate. Okay, so that's the major product of this reaction. Now, this added group of glycerolide 3-phosphate, it is normally oxidized to a carboxylic acid, and this carboxylic acid is just what? It is just the inorganic phosphate group, and this inorganic phosphate group, we surely know that it can simply produce what? Phosphoric acid. So during reaction number 6, which is involving the oxidation of glycerolide 3-phosphate to form 1,3 biphosphate biphosphogycerate, we need to understand one thing. One thing we need to understand is that this inorganic phosphate group is simply going to be dissolved in water to form what? The phosphoric acid. Remember that the cells, they have the water. So the acid, which is the phosphoric acid, is just coming from that inorganic phosphate group. And then this type of anhydride is normally called as an acyl phosphate. This anhydride is just known as what? An acyl phosphate. Okay, with that in mind, we need to understand that this acyl phosphate has a high affinity, okay, it has a very high free energy of hydrolysis. This reaction, or this acyl phosphate, it has a very high free energy of hydrolysis, and this energy is equivalent to what? Negative 49.3 kilojoules per mole. Okay, now what is the acceptor in this reaction? What is the acceptor in this reaction? So we need to understand that during the reaction number 6, there is an acceptor which is just NAD positive. So NAD positive acts as an acceptor during what? Oxygen, and the acceptor is just what this is just accepting is what? Hydrogen molecule. Remember, the phosphoric acid, the phosphate group, or the acyl phosphate, it's going to produce the hydrogen. Okay, since it's an acid, it simply means that it's capable of producing the hydrogen molecules. So those hydrogen ions which it has produced, there is another molecule which has to be present, and this molecule has to be able to accept what is being produced, and this molecule is just the NAD+. If you observe here, NAD+ is the one which is just which is accepting the what? The hydrogen what? Molecule, and this hydrogen molecule is coming from this compound which is the phosphate group. Now this hydride ion, since this guy is acting as an acceptor, so the hydride ion, it is normally transferred to NAD+, and this NAD+ will become what? NADH. So when the hydrogen react with this guy, it's going to produce what? NADH. And this is substrate level phosphorylation. This is just the substrate level phosphorylation. Let me quickly look back at reaction number 6. Reaction number 6 involves the oxidation of glycerol for 3-phosphate to 1,3 bis-phosphoglycerate. And then this reaction, it's just involving the glycerol 3-phosphate reacting with the inorganic phosphate, and this inorganic phosphate will produce the hydrogen ions, and these hydrogen ions, they will be accepted by NADH to produce what? NAD+. And this reaction takes place by the help of an enzyme which is glycerol 3-phosphate dehydrogenase, and then lastly that molecule will be produced. Okay, so guys, with this in mind, let's quickly look at reaction number 7. Now then, reaction number 7, there will be phosphoryl transfer from 1,3 bis-phosphoglycerates to ADP. There will be an issue of transferring a phosphate group from what? A phosphate group from 1,3 bis-phosphoglycerates to what? To ADP. Remember, our major goal is to produce what? To produce ATP. So at this particular reaction, that is where when ATP is being produced. So ATP is being produced from ADP when this phosphate group is transferred to what? To ADP. So what we had here, 1,3, okay, 1,3 bisphosphoglycerate, one of the phosphate group will be given to ADP to produce what? ATP. Remember, this is a payoff stage. Being a payoff stage, we need ATP to be what? ATP to be created. Now, an enzyme which is involved is just the phosphoglycerate kinase, and remember, magnesium is also involved. Okay, so guys, make sure that you go through this, make sure that you subscribe to my YouTube channel, and make sure that you are able to register with Excel Academy. So like I have already said, you need to understand that when this guy reacts with ADP, you need to understand that it's going to donate a phosphoryl group, and this phosphoryl group is going to lead to the formation of what? ATP. So during reaction number 5, there is a formation of ATP and the 3-phosphoglycerate. All right. Now, this reaction is referred as what? As substrate level phosphorylate. So the transfer ATP formation by phosphoryl group transfer from a substrate such as 1,3 BPG, which is just bisphosphoglycerate, is referred to as the transfer to substrate level phosphorylate. Okay, let's quickly move on and look at reaction number 8, which is a simple reaction. This reaction is just involves the conversion of 3-phosphoglycerate to 2-phosphoglycerate. Remember, in reaction number 7, there was a formation of 2 molecules, ATP, which we need for energy, and then now there is this other molecule which also need to be converted. So 3-phosphoglycerate is now being converted to 2-phosphoglycerate, and this is how the reaction takes place, and this reaction takes place by the presence of phosphoglycerate mutase. And lastly, we'll look at reaction number 9. So reaction number 9, it involves the dehydration of 2-phosphoglycerate to phosphoenolpyruvate. So this reaction, in terms of the diagram, this is how it looks like. So there is a conversion of 2-phosphoglycerate to what? To phosphoenolpyruvate, and the enzyme which is used is just the what? Enolase. Okay, now we need to understand that despite the relative small free energy of the reaction, so you need to understand this reaction has the small free energy change. Now, despite of that, there is a very large difference in the standard free energy of hydrolysis between the reactant and the product. Okay, I think that has easily been explained. So this reaction also involves the loss of water. This reaction also involves the loss of water. As you can see there is a loss of water from what? 2-phosphoglycerate, and this leads to the redistribution of energy within the molecule, resulting in increased energy of hydrolysis of the phosphate group. Okay, now this enzyme enolase is normally being inhibited by the presence of what? Fluoride. This enzyme enolase is being inhibited by the enzyme called what? Not by an enzyme, but by what? By fluoride. Okay. With this being done, we can just simply look at reaction number 10, which is just the transfer of a phosphoryl group from phosphoenolpyruvate to ADP. ATP. All right, so this stage is very important in such a way that this stage, it will also now produce what? Produce ATP, and then there will also be the formation of pyruvate, and this pyruvate will be explained. Its fate will be explained later on in the next video. And you need to understand that under cellular condition, this reaction is normally irreversible. So the last reaction, which is reaction number 10, it just leads to the formation of two products, which is pyruvate and what? ATP. Pyruvate and ATP. So what are we simply saying? What we are simply saying that there are two ATP molecules which are being formed. There are two ATP molecules which are being formed. Okay, that's very important. There is also 2 NADH which is being formed. So make sure that you know how many pyruvates are being formed from one glucose molecule. Remember, this is just one glucose molecule. So one glucose molecule will lead to the formation of 2 NADH and also 2 pyruvates and also 2 molecules of ATP. So these two, they are coming from that fact where the fructose 1,6 biphosphate was being cleavage, where it had to break down into 2 particular molecules, and that reaction, it had to take place during reaction number 4, where there was cleavage of fructose 1,6 biphosphate. So from there, you need to understand that one molecule which was produced was dihydroacetone phosphate, which was later on being converted to glyceroaldehyde 3-phosphate. And during the same stage, reaction number 4, where there was cleavage of fructose, there was also the formation of another or a second glyceroaldehyde 3-phosphate. So guys, make sure that you are able to identify or to know the stages. So from there to there, the enzyme involved up to the last point where pyruvate kinase is being involved. And remember that there are 2 molecules of pyruvate which are being formed. There are also 2 molecules of ATP and also 2 molecules of NADH which are being formed from one molecule of glucose. All right guys, thank you very much for joining me. This was Dr. Possibility from Excel Academy. Please make sure that you subscribe to our YouTube channel and make sure that you share this video.